Number 8, and for those of you watching, you might want to know how to do this problem. MI Fast rides his bike at a constant speed for 3 hours. Helped by a 4-mile-an-hour wind. So this is going with the wind. He rides for 3 hours at some distance. Pedaling at the same rate, the trip back against the wind takes 6 hours. Remember, that was an omission. There was a typo there. That should be a 6. Find the total round trip distance. So total round trip. So now to complete this problem, you need to remember the relationship distance equals rate times time. You also need to remember that the rate in this situation is made up of the bike speed and the speed of the wind. Okay, so we have two situations here. We have a situation where MI Fast is biking with the wind, and that takes 3 hours. And we have a situation where he's biking against the wind, the same wind, and that takes him 6 hours. So let's figure out what our variables are here. It's asking us for the total round trip distance, so that should be a hint that distance is something we don't know. The bike speed, all we know about it is that it is constant. We don't know what it is. So that's another variable for us. The wind speed is given. We know that the wind speed is 4 miles an hour. And we also know that we have a time going with the wind and we have a time going against the wind. So time is not a variable. So we'll let D equal, we're going to call it the one-way distance. And that's going to be important later. And we'll let T equal, no, not T, I'm sorry. We'll let B equal the bike speed. So now with the wind, remember the wind is pushing against the bike, it's helping. The distance is equal to the rate of the bike plus the rate of the wind, which is 4 miles an hour, times the 3-hour time going with the wind. Against the wind, our one-way distance is equal to the bike speed minus the wind speed, remember, because it's working against the biker, times 6 hours in this case. So now we have that distance is equal to this expression, but we know that same distance on the way back is equal to this expression. So if D equals one thing and D equals another thing, we can conclude that these two things must be equal. So we set up an equation. This is essentially solving a system by substitution. We're substituting for D in one of the equations. And we solve. 3b plus 12 equals 6b minus 24. If we subtract 3b from both sides and add 24 to both sides, we get 36 equals 3b, and that b is 12. And this is a bike speed, so it is 12 miles per hour. But remember, the question is asking us for our total round trip distance. It's not asking us for the bike speed. But we can use the bike speed to find the distance by substituting bike speed in for b in one of our original equations. So let me get a clean page here. we'll use the first equation. D equals b plus 4 times 3. And remember, we solved for b. It was 12 miles an hour. So substituting for b, d equals 12 plus 4 times 3, which is 16 times 3, which is 48. And this is a distance, so it's miles. But remember that d was only our one-way distance. So it's 48 miles one way. To find our round trip distance, we simply multiply by 2, and we get 96 miles round